Hey everybody, welcome back to the 164th episode of Taps of Patience. I am AJ with Subtract Manufacturing and Audacity Micro here with Harrison at Precision Ingenuity. Hi Harrison.
Hey AJ, how we doing?
I am doing all right. I can hear myself much more clearly than I normally can on the podcast because instead of wearing sound canceling headphones, I bought like legit studio headphones and I sound different in my head now.
Is that good? Is that bad? What is that?
Well, not being able to hear myself at all is bad. The noise canceling headphones definitely had some of that, like built in, some sort of kind of monitoringness. But I don't know. It's getting used to, or I need to get used to it.
Fair enough.
So, what have you been up to?
Well, I've been a loner, so work.
Yep.
So,
no wife.
No wife, so...
Well, long distance wife.
Yeah, long distance wife, so just been focusing on the shop and kind of entering, hopefully, a last push of stress before some major relief I've needed for a while. So, we've got one of our customers who we've had parts for a long time, and we've had a lot of hurdles, and I think we've overcome the final hurdles, so we can move forward, but we aren't making the parts yet. And if we can get them going, it's gonna be awesome. So,
Are these medical parts?
Yeah.
Okay.
So just trying to get all of our ducks in a row so we can start producing them on a regular basis. And they've been we had those, and then we had some other parts that were first articles that I talked about in the past. Those are now flowing. And so that has been a big stress relief. And then once we get these other ones flowing, that'll make sure that all jobs that we have are in good standing and moving forward. And it'll feel a lot better when that happens.
Nice.
So just one last stress push, and then hopefully it won't be smooth sailing because new problems will come up, but at least from a having parts that aren't going out the door and cash flow bottlenecks perspective from both of those sides of running a business, those should both be alleviated some as things start moving in the right direction again.
Okay.
So, because we've sunk a lot of time and money and resources into getting these things going and have nothing to show for it yet.
Yep. That's like the worst stage of any project.
Yeah. So getting those to where they're become revenue generating is going to be, and honestly, the revenue side of it is less stressful than just doing what's right for the customer and getting them good parts. So like keeping them happy, and thankfully, they've kind of gone through a little shook-up and a little shake-up during this time. And so they kind of admitted to me in a meeting last week that basically they were like, if you had gotten those done any faster, it probably we would have been behind you, and it would have put us in a different kind of a bind. And so it's they're kind of being generous to us in that sense, but I don't want to delay it any longer, and I want to get them going.
Yep.
So, and I'm sure there'll be small problems that we run into as the production starts flowing, but those are always a lot easier to deal with as production is going. So, as we kind of dial in our processes for repeatable long-term part making. So, yeah.
But it sounds like you guys are plenty busy even without that job right now.
Oh, yeah, we are. We're pretty busy right now. Although we are getting caught up pretty quick. So we're about to the point where we've got most of our normal job shop work cleared out and only have production type jobs going through the shop, which means we will have more capacity for job shop stuff. Although we have 4 or 5 production parts now, so that capacity has been going down as we've been taking on more and more production type work.
And potentially some plastic part small production run.
Yes. So we're looking into that, and that'll be exciting. So the more we can kind of get work where it's kind of on a monthly basis and we can plan that for our equipment, the better. So
that's a potential Subtract job for anybody listening.
Yeah. So we're looking at a Subtract job, and It's definitely not going to be the easiest parts, but they will be a fun challenge. So
I'm going to be honest, I haven't even looked at them yet.
oh, you haven't?
No, I haven't seen those parts at all.
You should look at them at some point.
I know they're plastic lathe parts. That's all I know.
They're pretty complex.
Okay.
And the annoying thing is it looks like they're all, I need to double check, but I think they're all UHMW, which is super stringy.
I think they're probably propylene, which is possibly the one plastic worse than UHMW.
Yeah, so that's the one thing that's going to suck about them. So, but it's nice. It seems like with dual spindle lathe work, it's either all or nothing. Like it's either sitting there doing nothing or it's slammed. So there is no middle ground with dual spindle lathe work. It is designed to run and run it enjoys. So I'm hoping that we can continue to get more and more work for it and keep it busy. So, but and then maybe get another one. So we've talked about, and I don't know if I've mentioned this on the podcast. Have I talked about my ST15 replacement?
Not recently, I don't think.
Okay, so one idea that I have floating in my head, and I don't know when this would ever happen, but we have two machines that are dedicated to 2.5-inch diameter work, and we get a lot of work that's 3-inch diameter and up. And we work with a local machine shop, and we trade work with them, and they have a machine that can run those larger parts. So we either have them run blanks for us, depending on what it is, or we just run them on a mill. Mm-hmm. And we've talked about switching out our ST15 at some point for like a Haas ST28 with live tooling and a sub. And then it would be almost the same size. It'd be bigger, but almost the same size as our ST15. And then we could sell that and have a bigger non-bar fed machine that can do up to 4-inch diameter.
Have you seen that Haas is coming out with a mill turn?
I have. I don't think I'd be able to fit that in my shop though.
Okay.
So
I think that's basically all we know about it, is that we're going to get a mill turn at IMTS this year. But
yeah, I've seen photos of it. So not that I can share because I was shown them on someone else's phone.
Yeah. I think you would be better off with something like an Integrex or like one of those other, I don't want to say real mill turn machines, but like a more established line.
Yeah.
But it might be a good, relatively cheap kind of holdover until you can, drop $1 million on an Integrex.
Yeah, and so that's going larger. What I'm thinking more for my mill turn is more like a Williman or I think Sukugami has a 5-axis mill turn that's kind of like that for Swiss. Something on that size, because a lot of these parts that I'm doing on my dual spindle Y-axis lathe would be much better suited to a mill turn, and I don't need a massive mill turn for the diameter of parts I'm running on them.
Yeah, that makes sense.
So I would like a little bit, I would like it to be up to like 2-inch diameter, I think, or inch, inch and 3/4 to 2-inch. And I don't know very many that'll go quite that big, but then there's like that middle space that I can't find very many machines in.
That would be awfully big for a Willy.
Yeah. So I just need it a little bit bigger, because I think the biggest they go up to is like 1.25 inches or 1.5 inches, maybe.
Yeah, it's probably like 30 millimeters or something like that.
Yeah, and I really need something that can go up to about a 2-inch to be able to do everything I want it to do.
I think that's a pretty big mill turn, though.
Yeah, I know it doesn't. But the parts aren't that big, though. The parts are like, they're just like bigger in diameter.
Yeah.
So like they don't feel like they're that big of a part. So they just need the space around them to be able to do that. So I don't know. We'll see. I'm a long time before I get it. Well, I don't know about a long time, but I'm going to try to hold out as long as I can before I buy another machine.
You say that, but IMTS is coming up. Should we start a betting pool? Like, what's the over under on when Harrison gets a new machine?
Datron says they're going to try to sell me a machine at IMTS. So we'll see.
I mean, that's literally why they're coming, but
Well, they're not coming to sell a machine to me, but like,
well, to everybody, they're coming to sell machines. They're going to try to sell me a machine too. They don't know who I am, but
yeah. But the salesman, I told him I'd swing by at IMTS, so. But I'd like to have a Datron. That's probably the closest machine that I'd probably buy at this point as my next machine, from a space, power, and workload perspective. Because like having my largest machine tied up running tiny parts kind of sucks whenever I do have other parts I need to run. So
just don't run other parts. Tiny parts are the way.
Yeah. So these are my highest margin parts, though. These tiny parts. Tiny parts have so much higher margin than larger parts.
You just outlined my entire business plan.
Yeah. So, but I don't get to choose what part. Well, I kind of do, but like with the customer base that I have, my parts have tended towards the medium size.
Yeah.
So I don't have many small parts in my area. Unless I did like Xometry or something. So, but what about you? Anything new this week for you? Or last week?
I've got a couple things. I'm still, working on my $20,000 in a month challenge. It is the 8th. We talked about that, right?
We talked about it. I was just curious about how it was going because are you on? Do you know if you're on schedule, above, behind?
So it is the 8th, and I am at about $9,500. So I'm ahead of schedule.
Woohoo!
I have a job to do tomorrow that'll be $800. This is I actually kind of regret the price I took this job for. I didn't. It should have been more. This should have been a $1,400 job. But it is what it is, and I have to make it now. This is the one I am worried about getting done on time. I think this job is probably a 2-day job, which is only $400 a day, which is not good for my needing to do about $1,000 a day. But I don't know. We're here now. Also, I originally ordered the wrong material for it.
Nice.
Yeah. So this is not going to be my best job in the world, but I did a couple jobs over the weekend that went really smoothly. Some little flat parts that I assume was some sort of like vacuum gripper, like a little 2-inch square that had some funky little, engraving with a 15th thou end mill on it. And then I made some of these like little castle bushings that I think were supposed to like fit on a shaft and fit together somehow. And that was not a very high margin job. Well, actually, that's not fair. It was high margin in the way that it was basically 100% because I had the materials and tooling on hand. In terms of like dollars per hour, it wasn't too great, but that was a good example of how jobs should flow through my shop, where like that was on intern day, and it was like I gave him program and a setup sheet that came out of AMERP, and then he made the parts, and then I inspected them, and they were all good, and then we packaged them and shipped them. And so while it was only like, I don't know, $50 an hour or something like that, or $70 an hour, it was like, there was no confusion. It was all stress-free. Like things just went. So the only problem we ran into on that one is we ran out of printer paper, and I couldn't print off a drawing for him to like measure them on himself as he was making them. So instead of recording our in-process checks like we normally do, I just inspected them all at the end. Let's see. I have a big job of hardened steel, I believe it is. Hardened tool steel coming up here next after I finish off this job that I shouldn't have taken tomorrow. It's like 50 pieces of these little like sawtooth things, or maybe shark fin things is a better way. They've got like 3 shark fins in a row with some pretty tight tolerances on them. And they're relatively hard steel. So they're like 45 Rockwell or something like that. So not knife steel, but not soft. And I realized that my plan A on work holding for them is dumb. because I was going to hold them in a collet on my not a fifth axis, and like machine from one side, flip and machine the other from the other side. But I know that not a fifth axis has a Z alignment issue. Like basically it tilts down a little bit. That's like 0.3 per inch or so. And these parts are like 2 inches long. And no, they're longer than that. They're like 3.5 inches or 4 inches long. And that will blow my tolerance. And then also, it's just going to be a tuning fork.
Yep.
So I have round bar, but I think I'm going to have to hold it in soft jaws and run it like a normal part. So I don't know. That may come back to bite me, but we'll see. I have until the end of the month to get those done. I have 5 days budgeted for them, but we'll see what happens in reality. It could be one of those things where I set the first one up, it works great, we're printing money. I run the other 49, package them up, slap them on the bottom, put them in the mail, and like let them go. Or it could be one of these things where I'm fighting them for the next month. So this will probably make or break my 20K goal in June.
And yeah, that will be challenging.
So the actual geometry is simple. They kind of have the long, skinny part problem, and then some the precision tolerances on them. That's
what was the tightest tolerance?
It's definitely sub thou. I need to double check, but I believe it's 0.5.
Okay. And is that on a bore, or is that like a thickness, or what?
No, it's feature? On like basically the shark fin. The shark fin isn't actually a shark fin. Yeah, it has parallel sides, and it's on the thickness of that shark fin.
Okay. Can you do it with the same tool in one op?
Probably. I certainly could if I was doing it via the not a 5-axis. If I'm holding it in if I'm holding round bar in soft jaws, I don't know if I can.
Okay. Because if you have to break that into 2 different ops, that's going to be really hard.
Yes.
For repeatability. Like you might be able to get it, but your scrap rating is going to be very high.
I do have lots of extra material. And I could do it in the flux, which would help.
Could you just add an extra op and just have it finished, in the beginning or end?
I wonder if I could do it with dovetails. Because I could even do it in dovetails, and instead of it sticking out actually on my not a 5th axis, I could dovetail it and like grab Jamie's barnacle, or I don't want to grab Jamie's barnacles. Use a small dovetail vise such as the JSpec Engineering barnacle and hold it radially on the not a 5-axis. Because that I trammed in, and I know it's good to like 1 or 2/10 across a couple inches. So actually, yeah, if I could turn these 90 degrees to how I was planning, and maybe it just needs a custom fixture, that might actually solve a lot of my issues. That's a good idea. Because I could probably even do an op 0 and put some through holes on either side and then bolt them down into like a cradle. And that would take care of my rigidity issues too. That might be the way. Good idea, Harrison.
From someone who has no idea what the part actually looks like, I'm glad I was able to help.
It's literally like, imagine like a side view of the ocean with like 3 sharks coming out of it, but they're kind of stylized shark fins.
That's funny.
So
fair enough.
This is why we do the podcast. This is great. You may have just saved me like 2 weeks of struggle.
Well, I always look at parts when I'm programming in terms of their hardest features and what's the best order of operations to make those features as easy as possible to machine. So like I don't always look at it in least amount of setups as much as I do what is the best way to get the best result regardless of setups. And having a 5-axis makes that a lot easier, I will admit. But there are definitely instances where even in 5-axis, I have to figure out how I'm going to hold it to be able to access multiple features. And I have to make sure that I can access all of those features and then still hold it in a 3-axis setup to finish it off.
Yeah, I essentially had the everything's the same size in CAD problem here because I wasn't thinking about the length of this thing. I would, in my world, it's like, oh, it's coming out a 1/2 inch bar. A 1/2 inch bar is basically infinitely rigid for the type of parts that I make and the type of machining that I normally do. But in my head, it's like a 1/4 inch long or, a 1/2 inch long. And that amount of stick out of the 1/2 inch bar just is a non-factor that I don't even think about. And then reality sets in when the material shows up and you're like, oh, this thing's hanging out that far. And that is just going to pling.
Yep.
This material was my first Subtract order.
Oh, really?
I placed an order with Subtract.
Oh, nice. So wait, you're ordering from Subtract and then you're doing the job yourself?
No. So the job is separate, but I needed the material heat treated. So I had to pay a shop on the Subtract network to heat treat the material for me.
Gotcha.
And so Audacity placed a purchase order with Subtract, and then Subtract placed a purchase order with Scott Tool and Machine, who ordered the material from McMaster and heat treated it for me and then sent it to me.
Gotcha. Okay.
We could have gone direct and it would have saved money. But at this point, ordering it through Subtract is just so much easier than like mailing him a check or whatever people do nowadays.
Gotcha.
But basically, Stripe was the winner out of that because Stripe got their 2.9% or whatever their credit card processing fees are, as I paid myself.
You couldn't just transfer between banks for yourself?
But that does weird things for accounting.
Oh, okay. That's fair.
So, don't just keep everything all the same.
That's fair. What else you got going on?
So I'm still working on my Kanban implementation. I'm slowly getting things Kanban. I guess what you do in a Kanban implementation.
Any movement on the robot?
The robot, yep, Mongo is making progress. Harrison's very uninterested in Kanban. Mongo is now controlling the auto door and is kind of sort of almost able to control the palette release.
Mm-hmm.
We have it set up as a logic OR, so it can be either the manual knob or Mongo can trigger the valve.
Mm-hmm.
But what we didn't foresee is with the current valve setup that we have, if you push air through one side, it vents out the other side. Like if you push air from the Mongo solenoids, the way the valve is set up, it vents out my little manual knob and vice versa. So we need some check valves, basically.
So you don't, okay, so you have two sources to one input.
Yeah. One output, yes.
Or one
two
output.
Inputs to one output.
Okay.
So we need some check valves to figure that out. So actually, I might have to think through that. That's what interns said, but I might need to draw a diagram before I order anything.
Yeah, what type of valve do you have? Do you have a five port valve?
Probably. I think so.
You need to look at the diagram for it, or is it a 4-port?
I don't remember.
Okay.
It's like a push pull thingy. It's like you either push it in and that releases it, or you pull it out and that stops it from.
But it has a solenoid on it, or
that is the manual one. So that is just a human operated button, and then the solenoid is whatever it is.
So, but do you not have? Okay, I see. So your manual is going to the valve, going to the solenoid, or is it?
No,
or is your
there are two separate valves. There's a solenoid and then there's a valve.
Oh,
so it's not electrically connected; it's pneumatically connected. It's a pneumatic OR gate was our goal.
Okay, so what you need to do instead, I think, if I'm understanding everything properly, is you need to have your manual gate going into the relief side of your pneumatic gate.
Oh, that makes sense.
That way, when the solenoid is over and the robot's not telling it to give pressure, when it'll vent unless you turn on the manual valve, and then it'll pressurize.
Yes, that is the way.
So that way,
Harrison's full of all the solutions today.
Yeah, you can't have both valves go into like a opening like that, because like you said, you're just going to be venting out whichever side is set to vent.
It does. We learned that.
So what you need to do is you need to have your vent side connected to your manual valve.
Yeah. And let's see, if it was if the solenoid was by itself, the order of operations wouldn't matter. We could have either one first in the chain. But because the solenoid is part of a bank of like 6 that share vents, we can't. So, yeah. Okay. That makes sense.
Yeah.
I'm on board with that.
You got any other questions? I'm ready for another challenge.
Lottery numbers this week? Let's see. We made a dumb mistake with our favorite customer with Subtract.
Okay.
When we sent them a quote, we quoted it in business days.
Mm-hmm.
And then at some point somewhere along the line, somebody looked at that quote and started communicating with the customer and told it to them as if it was days. So even though the original quote said, X business days, we then started talking in terms of X days, which is about 15 days sooner than we were actually able to make the parts, because we kept it together when talking to the shop. So when we talked to the shops, this order got split out between 3 different shops, one of which being me. Like, because the purchase orders to the shops were automatically generated by SERP, the information was correct on there. And so it said 35 business days. Actually, it even automatically did the math to figure out when the date was. But the customer is expecting the parts to be 15 days earlier. So we are scrambling to get those done. Kyle's the one who's making the parts, which is fortunate because he is near Jacob. And so Jacob's going to be Kyle's employee for the next week. Of course, it's a big order. It's if you go watch the Kyle Kirsch shop tour, you can see a cart that is loaded with a solid, basically block of aluminum. It's that material. That's what's being processed. And it's 6 operations. We had to order some custom form tools, which is what really added to our lead time. If it weren't for those form tools, it wouldn't have been a problem. But it was really the only reasonable way to make these parts.
Gotcha.
So we're scrambling now to make sure that those get done on time. Basically giving Kyle everything we can give him, including Jacob. And we're, working with the customer to set up more of a release schedule. So instead of delivering all of the parts on the target day, the original one that we told him and not the one that was on the purchase order, he doesn't need all of them that day. And so we can split up the order into a couple batches, and that helps.
Yeah, that buys you some days.
Yeah, which then interestingly led to basically the whole argument of single piece flow versus batch production with Jacob, because Jacob was like, "Oh, but there's this thing has 6 different setups, and he's going to have to do a lot more setups if we split it into batches." And but by reducing the batch size, we also get parts to the customer sooner, which keeps the customer happier. But it does certainly add a burden to the shop making the parts.
Yeah, it adds more setup.
Yeah, I just thought that was kind of a very interesting, it was like a textbook argument. It also made me realize that the way Subtract is set up, it does almost incentivize the batch work over single piece flow because they just have one target deadline. Like we don't have things built into our system that unless the customer specifically requests it, where they can ship batches early or whatever, like they just have a due date. They have to make all their parts by that due date. And so the incentives in the system are to make all the parts with as few as possible changeovers, which means you do a big batch of all of them. Just, I don't know. I don't know if that's necessarily avoidable or something we should try to avoid. It's just, oh yeah, this is why people still do big batches, even though there are, I would argue, bigger benefits of doing single piece flow for everything.
For sure. 100%.
Because the economics kind of encourage it sometimes.
Yeah, and for lathes, it's even worse because the setup time is a lot longer. Another advantage of B-axis lathe, it's got a tool changer.
Unless you can single piece flow from your lathe.
Yes, but to your point, if I had 6 different SKUs that all had to go through the same machine,
fair,
then I'd have to. And typically for us, like a fast setup on the lathe is probably 2 hours. Depending on how much crossover you have between what you were doing with it last, it can be less, obviously, but like a realistic setup time is probably close to 2 hours. So, which we're trying to do things to reduce that, but it depends on how many tools you have to pull off the turret.
Yeah, I had to pull my 0 point off for actually the parts on the same job. They were just too big to do into my little row of vices. And put my big 6-inch vise back on. And man, I was reminded how much I hated that. Like, not only, hauling around the big 6-inch vise and tramming it in and, having to change all of my work coordinate systems because I lost them all because I had to take my row off the table. I was able to keep the not a 5-axis on the table, which is good because that thing's the most annoying to get dialed in. But, like, I don't know. It's just a huge pain. And there's shops that live like this every day. I can't imagine not living with a 0 point anymore.
So that reminded me of something that's a little bit different, but it was also kind of a first for us in a while. Employee Ben broke his first probe tip.
Oh, just the tip?
Well, just the tip.
Gosh. That wasn't even intentional. He didn't crash the probe.
He didn't crash the probe. Just the tip.
Gosh, first we got Jamie's barnacles.
Yeah, so he was going to probe in a part, and he thought he clicked the Y-axis, or no, the Z-axis, and the probe was down in a hole, and just the tip, and then it wasn't moving, and so he clicked on the hand jog, and it did not do the Z-axis. Yeah, he clicked on the hand jog. This is going downhill so fast. Anyways, he ended up moving it in the Y-axis instead of the Z-axis, and was looking at the screen to make sure, and then it just snapped in the background. And so he kind of came over to me all sad with it in his hand, like, I did a thing, and it wasn't good. So
yeah,
I had to show him the process of dialing in a new probe.
In my last class, we had a student who did almost exactly the same thing. They had just touched off the top of the part, and they were going over to the side to get the side, and they thought they hit X, but I didn't confirm this, but I think they hit X on the keyboard section instead of the arrow section, and they were still in Z, and they went, cranked it fast.
Yep.
So it's easy to do. I can't say I haven't done that or something very similar.
Yeah. So we got that all dialed in and fixed up, but it took a little bit. The probe needed to be cleaned. I hadn't had it out of the machine in a long time. So it had a whole bunch of coolant on it, caked on coolant that had dried and left its residue behind for several months. So it was good to pull it out and clean it up anyways. But yeah, so we got that all straightened up, and I got to show him the woes of dialing in a probe and how much fun it is to try to get all those set screws in just the right spot. And he's like, "Man, this sucks. There's not a better way." I'm like, "No."
I make my students chant the mantra while they do it, which is find the low spot, loosen the front, tighten the back. Find the low spot, loosen the front, tighten the back. And if you do that enough times, you eventually get there.
Yeah. And so we slowly worked it in, and it's all set up now. So, how do you have Haas machines at your shop, right? How do you dial in the Z-axis? Do you just
boop it on the booper?
That's all you do?
Yeah.
Okay. That's not the most accurate way.
For my Tormach, I will still go through that. Actually, no, the Tormach doesn't even let you boop it on the booper. But I will. This is what I would do if I wanted to be really accurate on a Haas. Is I would go through their calibration stuff, and then I would take a tool, measure the length of that tool, face off a piece of material, and then probe that, and look for the error, and then correct the probe length by that error.
Yeah, and that's what we did.
Yeah.
So we went through the Haas routine, and then after it was close, we went in and probed it the rest of the way. And I think it was 0.8 off, which isn't horrible, but
that's more than I would have thought.
But oh no, I've seen it 1.5 off.
Yeah.
So it depends. I found out it depends on where that probe is on the little pad on the tool presetter. You know, if it's perfectly in the center, it needs to be like 1/3 towards the base of the tool setter to get it to come out almost perfect.
That's interesting. When you dial in the parallelism of that little tool setter pad, what standard do you do it to? Like, how much deviation do you allow across it?
I try to get it 0.2 or better.
Okay.
So I think Haas says within 0.4, I think, something like that. But I mean, I always try to go for perfectly flat if I can get it.
Yeah, I tell my students 0.2, but I didn't know if I heard that somewhere or if I just made up a number or what.
I think Haas says 0.4.
Okay.
But I always try to. I always aim for perfect, but you know, if it's within 1/10, I might stop messing with it depending on how long I've messed with it.
Yeah.
So
that is something my students struggle with more than anything else.
Oh, is what?
Is dialing in the parallelism of that the little pad, especially in X. They don't struggle too much in Y, but X really throws them off because it doesn't pivot around the center of that pad like they expect it to.
Which have you ever had to replace the pad of those because you've worn it out?
Not because I've worn it out. Well, no, I've never had to replace the pad. I have broken them off before plenty of times and had to put them back on, but
I've worn one out now officially.
Nice.
Like I had to replace it a couple months ago, but like it was not flat anymore because so many tools had been used on it.
The one on my Tormach definitely has a little random black dot in the middle of it, and I don't know where that came from.
So interesting. Do you do a lot of like rotating tool touch-offs, or do you do everything static?
Literally none, all static.
That's probably why.
Yeah.
I have a lot larger tools, and so anything over 3/8 of an inch, I want to say, it wants to rotate the tool and touch off. And that's where I can see a lot of wear on that surface, is that even though it's going in reverse, it still rubs it. And also, ironically, the very center of it as well had a line in line with how it boops down whenever a tool comes down on the center. And it looks like the center of it was almost engraved. So
yeah. I don't even think the Tormach has macros for doing its spinning.
Oh, really?
Yeah, I don't think that's like even remotely a possibility.
How does it do a face mill?
You line up the tooth manually.
Oh, really?
Yep.
Okay.
So it basically has a like auto align mode and then a manual align mode. And so if I touch off a face mill, I just choose a tooth, center it over the pad, and do the manual alignment.
But can it know where the tooth is based on that, and then auto align? Like, could you automatically check the face mill?
No. Well,
okay.
No. You have to manually line up the tooth, hit go.
Okay.
That's all you can do.
There's not an auto way.
Not that I know of. Norman may correct me, but
okay. I remember that from when I had a Tormach, but I didn't know if they had updated PathPilot with a way to do that.
It has certainly been updated a number of times, but I don't think that is a thing.
Okay. Fair enough. You can do diameter, though, right?
No.
Oh, you can't do diameter either?
Nope. I'm pretty sure the tool setter is capable of it.
Yeah, because it looks like a Renishaw.
Yeah, but no, there's no macros for it.
Interesting. Well, okay. Fair enough. Yeah, you definitely wouldn't be rotating then if you're not doing diameters. Because that's the main reason for rotation whenever I use it is for the diameters. That and large tools, larger than 3/8. So, okay. Yeah. The robot is back in heavy production mode. So
nice.
I'm very excited about that. It ran all last week, and it's going to be probably running solid for the next month or two or more.
Guitar parts, medical parts?
Firearm parts.
Firearm parts. I forgot about the firearm parts.
Yep. So I'm getting to the point where I'm finally getting some of the larger orders I thought I was going to be getting earlier this year. Mm-hmm. And so I'm getting a later start on it that I would like, but that ball is starting to roll, and that makes me very happy. So guitar parts are not doing so hot at the moment, which I kind of suspected. I was hoping, and at the beginning, whenever they went to their first trade show, I think they thought they were going to be flying off the shelves, and they got a little excited. But I think they're realizing now how much harder it is to get a new product introduced to the public, and especially getting the public interested and trained on what makes your product different. So,
yeah,
kind of that red ocean, blue ocean.
New products are not an easy thing.
So it'll be interesting to see how it goes. I hope it takes off, but they haven't sold very much in a while. So
shame. But they're going well on your end. It's not your end that's the problem.
It's not my end that's the problem. No.
Yeah.
So other than that, we had a major storm come through this morning, and it scared the crap out of me this morning. My alarm didn't go off, so I think it kind of saved me in a sense, and not sleeping in. But I had a lightning bolt that I swear was right outside my window, and I about crapped my pants. I needed a change of underwear after that, because it sounded like it was right on the other side of my window, and it lit up my whole bedroom like it was the middle of the day.
Yeah.
And a few cats might have gone flying as well. So it was quite the event. So
is that just a natural reaction of yours? Like you get scared and kick a cat?
No, they jumped on their own. They were not expecting it either. Although I have punted a cat off the bed unintentionally.
Who hasn't?
They have since learned to not sleep on my feet, because that is just a catapult waiting to happen.
We've had a couple pretty heavy storms go through this year. We're like way behind on cutting up trees that have fallen down. We have so much cleanup to do. We were like starting to get behind last year, but this year we've had just, big old branches and trees, and like most of it is in our, the back portion of our yard where like nobody goes there. It doesn't matter. It's fine. But like it gets annoying to mow around and stuff. We need to tackle that. Well, and speaking of tackling things, we have Patreon. Oh, never mind.
I had one more thing that I just remembered before we get into Patreons. So you know how we have a fiber laser?
Mm-hmm.
It died.
Uh-oh.
But I think we figured out what it was thanks to AI.
Oh.
So we've had, I think, 4 fiber lasers die in the last 5 years.
Mm-hmm.
And I think it's because of dirty power in our shop.
Oh, interesting.
And so when we bought the CMM and we bought the robot, we put power cleaners on both of those. And doing the research, we've had 2 fibers die in the new shop, and based off of usage, AI was like, it sounds like it's most likely dirty power that's causing them to die. And so it makes me really glad we put the power cleaners on both the robot and the CMM. So if anyone else out there is, a small shop or something, and you're worried about dirty power, it can affect things like the fiber lasers that most people get from like OM Tech, for example.
How does a power cleaner work?
So what it does is it monitors the power that's coming in, and it helps with like brownouts and voltage spikes, and making sure that the voltage just, so unlike a surge protector which only grabs the peaks, this tries to balance everything out and keep it like from shifting at all. Like it doesn't just prevent the extremes. It has a much narrower band that it tries to keep the power in.
Is it like a UPS that has a big battery in it, or is it all just capacitors and magic?
It's the same size as one of those that has like a battery, but it doesn't have a battery in it, and it just cleans the power.
How much are they?
So it depends on the size. You can go up to 200 amp on 110, or not 200, 20 amp. 20 amp on 110.
One circuit, that makes sense.
Yeah, one circuit. And for a maxed out one at 20 amps, I want to say it was like $1,500. But if you get down to like, say 5 amps, I think they're like $100 to $200. So I'll have to look up the brand that we use. We need to order some because I think we're going to put them on our fiber lasers now because it's obviously killing them.
Yeah.
And see if that makes a difference. But I think that's what's been killing them because literally last week we were engraving parts and it was going great. And then a part got engraved and then they loaded up another part and hit go, and it did all the stuff. It made all the noises of the galvos going, but the laser was just not working.
You like can just replace the source at least, right?
It's 90% of the cost of the laser.
Oh, fair enough.
So, because we've had this happen before, and we've asked them about that, and it costs 90% of the laser.
Because the rest of the laser is 2 mirrors on a stick.
Yes, exactly.
Or a mirror on 2 sticks.
Yeah, 2 sticks with 2 mirrors.
2 sticks with 2 mirrors.
X and Y.
It's not one mirror and... Never mind, it doesn't matter.
But the point being that thankfully we have a backup laser because of what happened last time. But I think we're going to get a power cleaner and a replacement laser down the line. We'll have to replace it again.
Do you think like a UPS would do it?
I don't know. That's why I did the power cleaners. Hang on. What does AI say? I'm curious because I want to learn. Is this... All right, you ready?
Yes, save us from the song.
So a power cleaner, often called a power conditioner or line filter, focuses on improving the quality of the AC power by reducing noise, voltage ripple, and electromagnetic interference. EMI, RFI. Whereas a battery surge protector is designed to absorb or divert large transient overvoltages, such as from things like lightning strikes. So in this case, the dirty power is going to be more from like voltage ripple or line noise, and it's destroying the sensitive electronics of the laser, which is what was the reason we got it for the CMM, because they told us when they were installing it, hey, if this is on a circuit that's connected to the CNC machines, it needs to have something to protect it.
Yeah.
Because it will destroy it as well.
The more you know.
So, I'd never thought about that in terms of our lasers, and we've obviously gone through them in the past, but this time, whenever it happened, we were looking through it and going, that's probably what's happening, because the AI basically said, like, you're not using it anywhere near enough that source should go out naturally. Like, something is causing them to die.
Yeah.
So
I'm having flashbacks to working at the air compressor company, because we definitely had to do something with our machines that were on inverters. And I don't remember what it was, but we had some sort of power filtering requirement, because those things were like, some of them were like 1,000 horsepower, and 1,000 horsepower will not only screw up all of the power, or especially on an inverter, which is really nasty power, will not only screw up the power for your whole building, but also like significant portions of the town. Mm-hmm. So what did we have to do? I vaguely remember something about that.
Yeah, and so it says here, power cleaners reduce continuous low level interferences, minor sags and peaks, improves performance of sensitive electronics and audio/video gear, whereas Surge Protector only handles short duration, high energy events. It is not intended to fix ongoing issues.
Well, uninterruptible power supplies do a little bit more than just surge protecting, because they help with like brownouts too.
Yeah, but that would be considered as a short duration, high energy event.
Yeah.
So, like if it goes too low, yes, it will. I think what happens with these is it does, if you have a brownout event, it just cuts the power instead of letting it go down low.
Yeah, that makes sense.
So, you just don't have the battery in there. So if you want the ultimate experience, you do a battery and then you do the voltage cleaner.
Yeah.
And then your device. So
I finally got the output of my air compressor hooked up to a electric valve and on a timer. This is tangentially related, but now my air turns itself off at the end of the day.
Speaking of another thing, I think we had 2 different devices in the shop die because of the lightning today as well.
Oh, really?
Potentially, yeah. So we had a solenoid that was set on a timer to leak out air, to let the water drain out on the big air compressor. And we had a guy come into the shop and he's like, "Hey, something's leaking outside." And we checked it and the relay was stuck open.
So it was just,
yeah. They've been doing that for all day. So that was fun. And our ceiling fan won't turn on now.
Really?
So
like a motor on a stick got taken out by the lightning.
Or we had a power surge today. So
yeah, but it's a fan. It's a motor on a stick with 3 more sticks.
It is controlled via a wireless remote, and so the sensitive electronics in that might be fried.
That's a bummer going into summer.
Yeah, so I need to see if we can. I didn't check the relay to see if it, or any of the relays to see if they got triggered, or not relays, breakers. I didn't check any of the breakers to see if any of them that got triggered. So it could be a breaker, but I don't think so, because that would be a weird thing for the breaker to trigger with everything else not being okay. So, but anyways, so I've had a couple of weird power things.
Yeah.
Between this week and last week. Between the storm today and last week. So.
Yeah. I haven't had to deal with anything like that. Just my Ethernet cable between my shop and my house suddenly dying. That and the fact that getting 3-phase to my shop is going to be like $65,000 minimum.
Okay. Now my tangent is done. If you want to go back to what you were doing before I interrupted.
Patreons. We have Patreons and we love them as much as Jamie loves his barnacles. All of our Patreons at any paid tier get access to our Patreon Discord, which is a super awesome place to hang out. They do hangouts without us every Friday. It's just kind of become a great self-perpetuating community. So if you join Patreon at any level, you get that. If you want to participate in our Q&A, you can join at the free tier or a paid tier, and then you can submit questions. It's been a little quiet on that front lately, so more questions, please. That'd be great, guys. And we want to give a special shout out to G28 Machining. They're a precision job shop focused on solving tough problems. They are our top tier Patreon. They sponsored us at the sponsor Patreon tier. So they have an FFL, an 0702, which I think we talked about in depth last time, 5-axis live tooling. So if you need machining, particularly in the firearm space, go check out G28 Machining. And then our $15 a month or more patrons include, but are not limited to, CJ at CS Machine and Fabrication, Mike at G28 Machining, Brian at Headco, Ben at Black Fox, Matt at Modern Fuel, Russell M, Joseph E, Brian B, Jacob S, Chris at CDS Plastics, John S, Alex H, Avery M, Chris B at Putty Creek Precision, Josh at Leighton Machining, Millen Y, Devin C, Christian O, Stephen M, Horse Pulverizer Incorporated, Daniel R, James and Moultrie Made, Ryan at Strata Manufacturing, Kyle at Curse Machine, Devin at Sinister Machine Works, Greg at Frogtown Manufacturing, James N, Ben at Perkley Pair Prototypes, Cam S, Shep at Alderson Prototyping, Jacob at Zona Precision, Jason S, Joshua H, Christian Z, Leland B, Freaky Climber, Prescott at 1Z2Z Systems, Trey V, Alexander B, Scott Design the Everything, Jamie at Nautical Work Holding, the maker of the Barnacle, Chris at Zyke Precision, EJ at Nocturnal Welding, Chris at Thought Bomb Designs, and as ever, Jake Brownson. If you would like to be a Patreon, and I think this is the last time that this joke will be funny, you can find the Patreon at nauticalwh.com. If you would like to subscribe to the YouTube channel, which we would greatly encourage, we want to get to 1,000 subs so we can monetize it. You can find that at nauticalwh.com. Or if you'd like to buy Jamie's Barnacles, you can do so at nauticalwh.com. Different spellings will get you different results.
Very nice.
I told Jamie that I wanted 5 or 6 of his Barnacles. He said he only had 2 in stock, but he would work on more.
Nice.
So he also said that he had a batch of miscolored ones that he was looking to offload. Actually, no. He did not say he was looking to offload them. He said he had a batch of discolored ones on his podcast. And I said, I will buy those for a discount. But I don't think I've heard from him again. Googling Barnacles is not the way to get to Nautical Work Holding.
No. And depending on how you're spelling, you might get different results.
Yeah. His Barnacle is only $50.
Yeah,
Jamie sells
nice.
his Barnacles cheaply. And I think I want several. So it'll be the cheapest way for me to get a lot of work holding for the for Mongo. The only problem is you have to do op zeros. And if you're going to do op zeros, then you need as many vices as you do Barnacles.
Not necessarily.
Assuming you want to hit go at night and then have enough op zeros ready the next day to load up all of your op ones and hit go.
No, because like during the day, if you can schedule your vices to go first and just keep them fed on if you have 3 or 4 vices where the robot is always going, and then if you don't get there in time, you have a couple barnacles ready to go.
Yeah, that's true.
Then you can just keep slowly filling up the barnacles, and then if you ignore it, you'll have all those barnacles that it'll just default back to.
Yeah. You could also have it run op 0, op 1, op 2, op 3, and then while it's running op 1, op 2, op 3, you take the material out of the barnacle or material out of your vice and single piece flow it that way with someone changing it while it's offline.
Yeah.
Okay,
Yeah.
That's fair. But yeah, I'll probably buy at least 5 barnacles.
Mm-hmm. We do have one question this week, it looks like.
Oh, yeah, we do. I was busy staring at Jamie's barnacles.
Why are you looking at Jamie's barnacles?
Joshua H. For AJ and Harrison both, since both of you guys have taught CAM/CNC, do you think AI CAM like Toolpath can be used to help train new machinists? Or do you think AI CAM should only be used by experienced machinists? That is an interesting question.
I think it's like ChatGPT. It could go both ways.
I don't think it's there yet. It's a helpful tool, but it doesn't get you to 100%. It gets you to 80% pretty reliably. And I would worry that new students would just accept it as perfect, accept it as gospel, and just send it without truly understanding some of the weird things that it does sometimes.
Yeah.
And like the weird things that can cause legitimate problems, not the weird things like, oh, it used a scallop on this chamfer and now there's a line that goes down the middle of my chamfer. Like that is a real problem the toolpath has, but it doesn't really matter at the end of the day. But like, I don't know. Sometimes like if it doesn't know where your work holding is, it's just going to cut into your work holding. And I know to look for that. And I will catch that 99.9% of the time. But someone just starting off who is overwhelmed by 1,000 different variables, I think it will eventually be a good tool. Just like ChatGPT is a good tool for like stuff and things. I don't know. But
I think if you didn't have a teacher and it was the only way you knew how to do machining, it could be beneficial and giving you some ideas on how to tackle different problems. And that's
fair.
That's the only case where I feel like if you went to a class and the teacher relied on it, I wouldn't want to do it. But if you don't have the opportunity to be taught how to do machining, I think it can give you a good idea on how to approach the part, as long as you understand it's not gospel truth.
It's basically giving you an example.
Yes. And it could be an incorrect example, but it's going to be mostly correct.
And at least it's an example specific to your part.
Yes.
The thing I would say is if the industry ever gets to the point where we are using AI programming for basically everything, like when modern CAM tools are to the point where they're all just automated, then yes, we should be teaching students using the automated systems and not, like forcing them to do it the manual way before they get to use the fancy new automated tool. But until that becomes industry standard, then no, I wouldn't yet.
And to that point, if it was to that level, why would you need to learn CAM?
I don't think the AI methods will ever be good enough where there will be no interaction at all. It's kind of like, we used to hand program programs by hand. And like now we have CAM systems that do it all for us, but at the same time, they're not doing it all for us by any means. And so I think the same kind of leap will happen with AI, where it will make it a lot easier, but it'll just let the person doing the programming focus on even higher level tasks.
Yeah. But it's also kind of like the difference between manual machines and CNC machines. Like it once you get to a CNC machine, it can do so much more than what you can with a manual that like you might not even have the desire to learn manual at that point because it can do so much of it in just the CNC.
Okay, okay. I see what you're saying. So you're saying why teach them the old method when the new method is taken over?
Yeah, exactly.
Yeah. Which is generally what I would argue as well.
So that's basically what I'm saying. Like if once it reaches that level, the need to use it to learn kind of goes away as well.
Yeah, because you would instead of teaching, what we call or what we use now, contemporary CAM. Instead of teaching contemporary CAM, you would teach future modern AI CAM.
Yeah.
Yes. My teaching philosophy is teach the tools that they're actually going to be using. Don't teach them antiquated tools. Like, sure, sometimes context is useful, but like if they need to drive screws, don't teach them how to hammer a nail.
Yeah. And the point I was trying to make is that if AI makes it to that point, there is no need for the manual CAM, period. Not that it'll ever get to that point, but if it was, you wouldn't have a need for the manual way of coding or of programming parts ever again anyways.
Yeah. We're going to get people who disagree with this, but I'm on board with that. It's just the same thing. Like I don't teach people how to hand code G code.
Yeah.
Can it provide valuable context?
Yes.
Absolutely. Is it worth my time teaching? No. Not in the time that I have with students.
Yeah.
It's
kind of like the difference between generalized and specialized knowledge. Once AI gets good enough, it'll be good enough for general tasks, general knowledge, general problems. There will always be edge cases, no matter how smart something gets. Just like you can find use cases for manual machines today, where it just doesn't make sense to do it in a CNC context. You will always find a context where coding or even hand coding things make sense, depending on what it is. But once you get to a certain point where the AI is good enough, that's all you're going to need on a basic level.
Yeah. And like when there's different levels of students. When you are first, like right now, the kind of modern, maybe modern's a strong word here. The traditional consensus of how you teach students machining is you put them on a manual machine, you let them crank wheels for a while, and then you teach them how to, manually code G code, and then you let them make like, a stupid little box doing that. And then you teach them CAM, and like, that's the top of their education. That's kind of the traditional education path for machining, going through the building blocks like that. I very much think there is value in knowing manual machining. And I think there's very much value in knowing how to hand code G code, but not for the entry level student. The entry level student needs to know how to do their job. And then once they can do their job, then you can add the historical skills in to provide context to what they're doing. Like, I think, like, I learned stuff watching like Alex Steele on YouTube blacksmithing. I think there's, blacksmiths have a lot of more of a feel for metals than a traditional machinist might. But I'm never going to start a student on blacksmithing before they get to machining, because blacksmithing was the context before manual machining. Like, how far back the tree do you want to go? Like, instead of starting them on manual machining, we treat them blacksmithing. Well, before blacksmithing, they were, doing woodworking. So we'll start them there. Before they were doing woodworking, they were, chopping down trees. Like, you got to choose a starting point at some point and then fill in the context backwards and stuff.
It reminds me of a story of an old machinist who was talking about when he went and got trained to be a machinist, where his first projects in school were using hand files to make parts.
That was very common.
And so, I mean, do you want to start a kid today filing something by hand whenever you're trying to teach him machining?
There are still lots of apprentice programs that do this.
Yeah. And that just doesn't, I don't think that makes sense in a modern context. And there's always going to be useful knowledge in the old way things were done, but that knowledge only matters depending on how deep people need to go down to do their job, like you were saying.
Yeah, it's supporting knowledge for the skill that actually matters.
Yeah. And I always want to have as deep of a knowledge well as I can on the subject I'm doing, but not everyone wants that. Not everyone needs that.
Yeah.
So I know that I love learning from any source I can find on YouTube and learning all this stuff that 90% of it won't ever apply to me. But there are definitely times when some of that knowledge comes in and it's like, ooh, I saw this video 3 years ago that was talking about a problem very similar to this, and now it's beneficial.
Yep. Yeah. Or like, again, I have learned things from Alex Steele videos that I have applied in my very modern machine shop. And, he's doing like old school traditional stuff. But like, yeah, there's nuggets there.
Mm-hmm. Have we beaten this horse? Is it fully?
I think this horse has been pulverized.
All right, guys. Well, we've reached the end of our podcast. We thank you. Yeah, apparently. So
I almost just hit the stop button instead of the music button. That would have been bad. Possibly our worst outro of all time if I did that.
Thanks for hanging out. And if you like this podcast, please like, subscribe, share, tell a friend, especially to YouTube. We need a lot of subscribers on YouTube. And we'll catch you guys next time. Taps and patience, our daily grind. In this machine shop, we'll always find joyous struggles, all intertwined. Taps and patience, one of a kind. Oh, is it time to go? It's time to go.
I thought you were giving me that hint.
No. I was just talking about the question.
Oh,
but I'm also good. If you're good,
I'm good. Okay. I've got to go make a part that I'm not ready to make tomorrow.
Okay.
Guys, this was a machining podcast that didn't talk about vibe coding. This might be the only one in like the last 2 months, like between us and, what's the Henry Holster's Pearson one and
Lean Think or something.
Yeah. John Saunders or the bomb. They talked about it. With Intolerance talked about it. Even the Arta podcast talked about it. We can mark ourselves safe from vibe coding this time.
I mean, I can add that in real quick if you want.